Welcome to today's ArXiv CS Digest for April 7th, 2026. We received 759 new computer science papers today across 59 subfields. Let's dive into the top picks. Trend 1 of 5, Coding, Graphs, and Quantum. This trend explores the intersection of advanced coding theory, graph theory, and quantum computing applications. This cluster covers 87 papers. Representative work includes multi-level coset codes on lattices on the $\lec_p $inversion diameter of oriented graphs and computational relative entropy. Trend 2 of 5, AI governance and explainability. These papers explore AI's decision-making transparency, accountability, and control mechanisms. This cluster covers 264 papers. Representative work includes Paper Circle, an open-source multi-agent research discovery and analysis framework, data, not model, explaining bias toward LLM texts in neural retrievers, and online learnability of chain-of-thought verifiers, soundness and completeness trade-offs. Trend 3 of 5, machine learning optimization techniques. These papers explore methods to improve machine learning model efficiency, accuracy, and adaptability through novel training, evaluation, and learning strategies. This cluster covers 150 papers. Representative work includes in-place test time training, topological characterization of churn flow, and unsupervised correction to the Wu flow regime map in small-diameter vertical pipes, and the character error vector, decomposable errors for page-level OCR evaluation. Trend 4 of 5, multimodal AI and vision models. These papers explore enhancing AI's understanding and generation across text, vision, and other modalities for robust and versatile applications. This cluster covers 140 papers. Representative work includes Halo Probe, Bayesian detection and mitigation of object hallucinations in vision language models, SimClip, unsupervised Siamese adversarial fine-tuning for robust and semantically rich vision language models, and MMEMB, R1, reasoning-enhanced multimodal embedding with pair-aware selection and adaptive control. Trend 5 of 5, Robotics and Video Generation. This trend explores using robotic systems and advanced video generation techniques for tasks like control, simulation, and scene reconstruction. This cluster covers 118 papers. Representative work includes action images, end-to-end policy learning via multi-view video generation, DiffHDR, re-exposing LDR videos with video diffusion models, and matrix, mass track alignment for interaction-aware video generation. Up next, our first paper out of 5, Online Learnability of Chain-of-Thought Verifiers, Soundness and Completeness Trade-Offs by Maria Florina Balkan and Draviant Sharma from Carnegie Mellon University. Let's break down its key contributions. Proposes an online learning framework for chain-of-thought verifiers to address distribution shift issues. This framework enables verifiers to adapt and learn from sequential data. Introduces novel extensions of the Littlestone dimension to characterize mistake bounds for learning verifiers. This provides theoretical guarantees for the learning process. Develops optimal algorithms for finding the Pareto frontier, balancing soundness and completeness mistakes. This allows for efficient trade-offs between different error types. Demonstrates how learned verifiers can boost the accuracy of weak provers. This enables generation of proofs beyond the initial training data. Shows how to learn a strong prover with small error and abstention rates. This relies on the assumption that at least one prover can generate correct steps. Up next, our second paper out of 5, Asymptotically good CSS codes that realize the logical transversal Clifford group fault-tolerantly by K. Simonish Reddy and Navin Kashyap from ISC, Bengaluru. Let's break down its key contributions. Introduces a novel framework for constructing Calder-Bank-Shorstein CSS codes. This framework is designed to support fault-tolerant logical transversal zerotations, forming the basis for subsequent constructions. Leverages the established framework to derive asymptotically good CSS codes. These codes fault-tolerantly realize the logical transversal Clifford group, enabling efficient gate operations. Investigates and constructs specific CSSD codes. These codes demonstrate the transversal realization of the logical transversal S-gate, extending the capabilities beyond the Clifford group. Revises and refines the characterizations of CSSD codes. This includes analyzing the conditions for transversal T-gate implementation, clarifying their behavior and limitations. Up next, our third paper out of 5, ActivityEditor, Learning to Synthesize Physically Valid Human Mobility by Chengji Yang and Junbo Zhang from University of Electronic Science and Technology of China. Let's break down its key contributions. This agent leverages demographic-driven priors to generate structured human intentions and coarse activity chains. It ensures high-level socio-semantic coherence for the mobility synthesis task. The editor agent refines the structured intentions into mobility trajectories through iterative revisions. It enforces human mobility laws and physical constraints for realistic outputs. The editor agent acquires its refinement capability through reinforcement learning with multiple rewards. These rewards are grounded in real-world physical constraints, internalizing mobility regularities. Up next, our fourth paper out of 5. LLMs should express uncertainty explicitly by Junyu Guo and Javad Levay from University of California, Berkeley. Let's break down its key contributions. The model verbalizes a calibrated confidence score for its final answer. This interface substantially improves calibration and reduces overconfident errors, enhancing decision-making. The model emits an explicit marker during reasoning when it enters a high-risk state. This makes failures visible, improves wrong answer coverage, and acts as a retrieval trigger. Training uncertainty as task-match communication, distinguishing between global confidence for trusting answers and local signals for intervention needs. This optimizes uncertainty's utility. Up next, our fifth paper out of 5, BodhiPromptShield, Pre-Inference Prompt Mediation for Suppressing Privacy Propagation in LLM/VLM Agents by Boma and Weiqi Yan. Let's break down its key contributions. The initial step of the framework is to accurately detect sensitive spans within user prompts. This ensures that privacy-critical content is identified and targeted for protection before any propagation occurs. Once detected, sensitive spans are then routed using type placeholders, semantic abstraction, or secure symbolic mapping. This provides diverse, context-aware methods to de-identify and protect information during its journey. The framework delays the restoration of sensitive information until it reaches authorized boundaries. This crucial timing mechanism prevents premature exposure, ensuring privacy is maintained across all agent stages.